Hi everyone, so today we're going to talk about end behavior of polynomials. And end behavior is the behavior of the graph as x approaches either positive or negative infinity. So let's look at some examples together. So you see two different graphs, both have a degree of 1. We have x and negative x. Now the degree of 1 is an odd degree. So the way that we read this is as x approaches negative infinity, which means I'm going to look at the left side of my graph. I want to know what my function is doing, what f of x is doing. So it's approaching negative infinity. The end of the graph is pointing towards the negative y values. So f of x is approaching negative infinity. Now, as x approaches positive infinity, I look at the right side of my graph. So my function f of x, it is approaching positive infinity. The line points towards the positive y values. Now, if I look at my second graph, as x approaches negative infinity, again looking at the left side of your graph, my function f of x is approaching positive infinity. And on the other side, as x approaches positive infinity, I look at the right side of the graph. F of x is approaching negative infinity. Now, if we go up a degree of 2, it is an even degree, and these are two graphs of parabolas. So again, as x approaches negative infinity, the left side of my graph, the behavior, what is it doing? F of x is approaching positive infinity. It points up towards the positive y values. And on the other side, as x approaches positive infinity, my function is approaching also positive infinity. With the second graph of negative x squared, as x approaches negative infinity, my function is now pointing towards negative infinity, towards the negative y values. And likewise, as x approaches positive infinity, my function is also approaching negative infinity. My graph, both ends are pointing towards the negative y values. The next degree, also an odd degree, same thing as I look on the left side of my graph, my function is approaching negative infinity, and on the right side of my graph, my function is approaching positive. Now with the negative x cubed, I'm going the other way. As x approaches negative infinity, my function is approaching positive, and on the right side of my graph, my function is approaching negative infinity. Going up one more degree of a degree of 4, which is again an even degree. Likewise, I have similar looking graphs with the degree of 2. And again, my function is approaching positive infinity when x is approaching negative infinity. And then x is approaching positive infinity. Again, my function is also pointing towards the positives. On the other side, I do have a negative infinity. How the graph is behaving, my function is both approaching negative infinity. Hopefully, you've seen a little bit of a pattern as I went through these 4 different degrees. And the two things that affect end behavior is the graph's degree, or that exponent, that power, and the lead coefficient. So what you'll see is that when you have any type of even degree, you'll notice that both ends are pointing in the same direction. If I have a positive lead coefficient, my function is approaching positive infinity. So it looks similar to a parabola. So use that as a basis because we're pretty familiar with parabolas. Now, if I had a negative lead coefficient, you'll notice that as a parabola is opening down, both ends of your function, f of x, are approaching negative infinity. So notice that both ends are pointing in the same direction for any even degree. Now, if I'm looking at an odd degree, notice that they are pointing in opposite directions. And if you have a positive lead coefficient, what you'll notice is it's kind of like a line. Even though the shape might be a little bit different, the ends are behaving just as a line. And we are very familiar with how lines are, so hopefully you can use that again as a basis to help you with any other type of odd degrees. Now, if you had a negative lead coefficient, it's like a line, but with a negative slope, right? Your little guy goes down the hill, he walks down the hill, so you have a negative slope. So you'll notice that looking at, again, the ends of your graph, you could use a line as a basis in order to help you with end behavior. Now let's look at some examples together. Given a graph now, you'll see as x approaches negative infinity, my function is approaching negative. And as x approaches positive, again, my function is approaching a negative infinity. So is the degree even or odd? So you'll notice that both ends of your graph are pointing in the same direction. So the degree is an even degree. I'm not really concerned as to what that degree is. I just wanted to know if it's even or odd. Now, looking at what you see here, is that lead coefficient going to be positive or negative? Now, they're both pointing in the negative direction. Your kind of like a parabola is pointing down, so it is a negative lead coefficient. Now, if I give you an equation instead of a graph, you can still use the same process to help you. Now, looking at the end behavior of this function, two things you should notice. The first thing is that you have an odd degree. That degree is 3, and you have a positive lead coefficient. That's the imaginary 1 that's in front of the x cubed term. Now, with an odd degree, you know that your kind of basis is a line, right? I'm familiar with a line. It's a positive lead coefficient, so it's going to have like a positive slope. So then looking at the ends of your graph, you can see that on the left, as x approaches negative infinity, your function is approaching negative infinity. And as x approaches positive infinity towards the right side of your graph, your function is approaching positive infinity. Now, here are a couple things for you to remember. Remember to always look at the degree and the lead coefficient in order to help you to determine the end behavior. And you can also use the shape of a line in a parabola as a basis as you're looking at higher degrees. I hope this video was helpful and that you learned how to determine end behavior of polynomial functions. Thanks for watching and have a wonderful day.